Hey robot makers, so you wanted to make the leap from the Arduino to MicroPython, but not sure where to start? Then this is the show for you. So let's dive straight in. My name's Kevin McAleer. Come with me as we build robots, bring them to life with code, and have a whole load of fun along the way. Right, let's get over to our keynote, shall we? So this is a show I've been thinking about doing for a while now. I've been familiar with Python and MicroPython for probably a couple of years now, and I've made the switch from Arduino to Python. But I remember when I was first starting out and I hadn't really cut any code in Python, and it was quite what's the word, intimidating, because I wasn't familiar with it. So I thought I'd put this together and we can do some kind of side-by-side comparisons of code as well. So before we get started on that, let's just have a quick step back and understand who these different organizations are. So Python, there is the Python Software Foundation, and they promote and protect and advance the Python language. So they're actually a company. They're not a foundation that's charitable, although that they are open source. They obviously need funding to exist. And Arduino is similar. They are also a company. They promote open source hardware and software, and we can have a look at the differences between those two organizations as well. So MicroPython, as it turns out, is kind of an offshooting, a fork of Python, and it was by I think he's an Australian guy, although I believe he goes to Cambridge University. So Damien George, 2013, so not that long ago, he created a reference board which is called the Pi board. There's a little picture of it there, and the idea there is that you can run Python, which is like a 32-bit language at least, running on a chip. So you need a bit more memory than you would an 8-bit chip, which is what the Arduino is. So he's taken kind of a subset of the Python language and squeezed it down into an executable that can run on this embedded chip. So let's have a look at the Arduino. So you're probably quite familiar with that if you're coming from the Arduino to MicroPython. So it's open platform, open hardware platform. It's actually a language based on processing. So quite a few people think, oh, it's C, C++. Kind of is, but it also isn't. Some of the nuances of Arduino, one of the reasons you call it a sketch, for example, is because processing was an artist's language. It was developed to enable artists to create electronics and sculptures and things like that. So they talk about sketches rather than programs. And that's one of the little nuances from processing. But it is very heavily based on C and C++. And that project began way before MicroPython. That's 2005. That project first kicked off. And the name Arduino actually comes from a shop. On Wikipedia it says a bar, but I don't think they mean like a bar where you drink alcohol. I think they mean like a coffee bar. And that's from Italy, where the founders used to meet. So here's a bit of a picture of that place. So you can see there, is it Pastoris? I can't even pronounce that, Pastoria. And that's Arduino. And that's the actual place where it's got its name from. And the region is Ardin. Is it Saint Ardin or something that's named after? It's all very meta. So let's do some comparison, shall we, between MicroPython and MicroPython versus Python. I think that should be Arduino versus Python. So Arduino code is machine code. So when we write our code in the Arduino IDE, that gets compiled and transferred into machine code that's executed on the, I find it easy if I had that little device in my hand, on the chip on there. So machine code is very specific to the board that you're using. So I've got an Arduino Uno here. If I want to run the same code on this little Arduino Nano Connect, for example, it's actually different machine code. The source code is the same, but the machine code that it spits out is different. So if I was to take the file generated for this and try and run it on there, it won't work. It's a different chip and different pins and all that kind of stuff. So it's very specific to the board that you're using. But that does mean it's very efficient. It's using absolutely no more than it needs to on the board, and therefore it's very efficient. And you can almost draw a straight line between language, code that's written in C, and machine code. You can literally draw a line between each command. So it's very efficient, creates very small executable files. But we do need to change the code. Changes to the code need to be made in the editor, recompiled and re-uploaded to the board every time you make a change to that. So MicroPython is different. So the code that you write for MicroPython is turned into something called bytecode. So it doesn't go to machine code, it goes to this reference library, this reference language that we create. It's like a virtual machine, very similar to how Java works. And the interpreter, which is running on the board, so in our case this might be a Raspberry Pi Pico or an ESP8266 or ESP32 or a microbit, that kind of thing. The interpreter that's running on these boards will take that plain English code, translate it line by line as it's executing into bytecode, and then it's the bytecode that then gets executed on the device. So that bytecode is actually transferable between any board running MicroPython because it's the same bytecode. So you can lift a file that's been written for one board and then run it on a completely different one because the bytecode is the same. The only nuance to that is if the pins are different, for example. So changes to the code can be made directly on the board via something that's called the REPL, and we'll have a look at what the REPL is in a minute or two. So drivers and libraries. So obviously this Arduino has been around quite a bit longer, nearly 10 years longer than the MicroPython language. And because of that, there is a lot more libraries available for this. Because it's open source hardware and anyone can build one of these devices without having to, buy the official one, which are quite expensive. Because you can do that, it's really been taken up by the community. People have built their own. You can get clone ones a lot cheaper than this. So because of that, there's a large number of libraries available, and the IDE, the integrated development environment for the Arduino, has all the library functions kind of at your command. So it's very easy to grab extra libraries for things, for extra boards that you want to plug into this. Very easy to do that within the IDE. You just go to the boards, the library manager. And the Arduino is a very mature ecosystem of library code. There's lots of tutorials out there because it's been around just so long. So it's very easy to find exactly what you're looking for. You want to find a blinking light program, whatever it is, you can find one very easily for the Arduino. So MicroPython, on the other hand, the libraries themselves are stored on the board or when you're using it. So when this needs to access a servo library or an LED library, the library has to be on this little board when it executes that code. Whereas on an Arduino, you build the code into the library code into the executable that gets stored on there. So it kind of gets cooked into the code. So libraries can be on MicroPython an MPY, which is it's kind of a compiled bytecode library that's stored on the board itself. So it's not necessarily plain text. It can be this in-between halfway bytecode. And there's a growing number of libraries on MicroPython, not as many as the Arduino yet. And because you have to pull the exact libraries that you need onto the board when you need them, you have to have them and load them into the board. So there's a little bit more involved than just going to the library manager and finding what you need, which is what you can do on the Arduino. But it's still quite simple to do, to be honest. So MicroPython is maturing. Python itself as a language is 30 years old, so it isn't that new. But it's now the world's most popular language, far more than C or even JavaScript, which is very popular. So EditCompileLink. So on an Arduino, this is the kind of old school way of compiling code. So you edit some code in your integrated development environment, source code, you compile that code. So what it will then do is create an object file for the target platform, target board. It will then link in those libraries, and it will either do that, it might even have to compile the source code for the libraries, but more than likely it's just an object file that's already been compiled, and it will grab that object file and put it into the executable that's being built up, and then you can then run that executable on this device. So as soon as you plug power in, it'll just fire up that little bootloader. The bootloader will find the executable in memory, doesn't have a filing system, and then it will just run that code forever until you release the power. So that's kind of the old school EditCompileLink way of developing code. Whereas on MicroPython, so on our Pico, we have this thing called the read, evaluate, print loop, REPL. And the REPL is a bit like on the Arduino where you have the serial monitor, where the REPL is an interpreter that you can type commands into over the serial cable directly into the interpreter, and you can evaluate things, you can print things out, and then you can execute next commands. And essentially when you build a script, it's just running it through that REPL in the background. It's just looking at one line at a time and remembering variables and things like that, remembering libraries, but then just executing the code. So code is read in, it's evaluated by the interpreter, results are printed out to the sort of console, whether that's through the serial. results, yeah, printed out, and then the process starts again. So that's the loop. So really it's just read, evaluate, print. It just keeps doing that forever. So development environments. So on Python, there are quite a few, because Python's 30 years old, it's got a little bit of a head start on the Arduino, and there are lots to choose from. So there's the original Python idle, which is the Integrated Development and Learning Environment, I think that stands for. It's horrible if you've ever used it. It's very basic. It does the job, but it's very, very basic. They've got my favourite, which is Visual Studio Code, a much more mature development environment designed for every language, to be honest. So you can even develop Arduino code in Visual Studio Code. It's built by Microsoft. They know a thing or two about developing software. So that's my favourite. Then you have Thonny. I do have Thonny as my go-to. It's still not my favourite because there's some shortcuts that are just not in there. So things like just being able to comment code out very quickly with like command and backslash, // you can't do that in Thonny, but you can see all the files nice and neatly at the side of the IDE. So I do like it for sort of uploading. And Thonny works really well with all the different MicroPython devices. So you can put in a microbit or an ESP32 or a Raspberry Pi Pico, and it plays nicely with all of them. It even plays nicely with some quirky hardware, such as this Sonoff, which I was just showing at the beginning of the video. And the Sonoff is a software on-off. You can build your own Internet of Things, like a lamp that you turn on via Wi-Fi. It's essentially just an ESP8266 on one of those little chips just there. You can build MicroPython on that, and Thonny will let you do that. So very, very simple. Then we've got Microsoft Make Code. That's designed for educational use. So you can have the block view, or you can use Python in there. Then you've got Moo, which is not as popular as Thonny, but it's on all Raspberry Pis. I think you can access Moo on there. And then you have PyCharm, which is a paid commercial development environment. They have like a community edition, but the paid version is the better version, but it's not free. So PyCharm is very good for developing Python code and therefore MicroPython. And then we have Atom.io. Atom.io is very similar to Visual Studio in its kind of look and feel. I actually used Atom for before I started using Visual Studio Code, and they've kind of caught up with and then surpassed, in my opinion, Atom. Atom I found slowed down the more extensions you added to it. It would kind of get slower and slower. So that's all the IDEs that I'm talking about today. There's probably even more than this that I haven't mentioned, but they're a good sample of them for the Python environment. And then for Arduino, I found they weren't quite as many. So there's one that's called Eclipse that's very popular. I think that's mostly a Windows platform. Probably will work on Mac as well, but I think it's mostly Windows. Then you've got Atom again. Atom is cross-platform, works on Linux as well as Mac and PC and Windows. Again, you've got Visual Studio, which works on Raspberry Pis, works on, I believe, Linux as well as Mac and Windows. And then you've got the Arduino IDE, which again works on Mac, Windows and Raspberry Pi, I think. They also have a web version and a Chromebook version too. So the Arduino IDE is kind of the go-to. It's designed by the people who make the board, so you would expect it to work well. And it's also supported very well by other companies such as Adafruit. They do a lot of libraries that go straight into the Arduino IDE software manager. So there's all the IDE environments. So let's have a look what else we have on here. Voltages, right. So this Arduino Uno, which I always think this is kind of like the reference platform, and even this isn't the first one. There's one with different USB connectors and different serial connectors and whatnot on them. They all use the same chip though, the ATmega 328P, I think it is. But they're all 5 volt. So this is what they call TTL. This is a standard 5 volts thing. So all the pins, all the voltages that go on the board, all 5 volts. Now that's a little bit heavy duty when it comes to like battery use when you're trying to develop an embedded system. It's great for learning things because a lot of components such as LEDs, got an LED somewhere to hand, they are all 5 volts as well. Whereas our friend the Raspberry Pi Pico and most other MicroPython devices tend to be 3.3 volts. And that means that we need to be aware of that, and we need to make sure the components we buy are kind of 3.3 friendly. So one of the components that I use very often, if I just grab this little OpenCat head here, this has got on it a rangefinder. So this is the, is it the HCSR07 some combinations of those letters anyway, and they're 5 volts. So if I want to use this with the Pico, I need a voltage splitter to split the voltage that comes back from one of the pins, otherwise it'll burn out this little thing. It will not tolerate 5 volts for very long. I have actually burnt out a few of these already by doing that. You can buy a different rangefinder that is 3.3 friendly. I'll put a link to that in the video when I find it. Off the top of my head, I can't remember what it is. I know it's something 0001. Somebody was discussing it in our robots group, which we'll talk about later. But yeah, the main difference: 5 volts for the Uno, and for the let's go back over to sorry, my Stream Deck's decided to go asleep there. Let's just go over to the overhead. So yes, this one, the Uno, this is also 5. Sorry, not the Mega. This has got a lot more pinouts, as you can see, compared to the Uno that I just had in my hand. It's got all these extra pins there and across there as well.
That's also 5 volts.
Let's just jump back to me. There we go. That's come back alive now. Thank goodness. He's just gone a bit asleep there. There we go. Okay. So yes, just need to remind you as well. I have a new video every Sunday, 7 PM GMT. Let me just put on that. It's a little bit jerky there. I'm not sure what's going on there. So yes, I have a new video every Sunday around about 7 o'clock British summertime. So hopefully if you're watching this and it's not summertime, you'll understand that it's 7 o'clock GMT/summertime, whichever the local time is for me. Yeah, I'm really looking choppy there on my own little feedback. I don't know if it's okay for you guys. Let me know in the comments if that's all good. What else have we got? And then the website, if you've not looked at smarsfan.com, I have a website that I run that's called smarsfan.com. I put all the tutorials on there. I put all the code and tutorials. There's the Smart Learning platform that I've launched a couple of months ago. Check that out. Let me know what you think. Lots of good stuff for you there as well. Good. Thanks for that, Dow Robots. Appreciate that feedback. Okay, and then if you want to support the show as well, yeah. So Richard said, "Is it me, or is it slightly out of sync with your mouth? Slight movements, slightly." I'm seeing that as well. I'm not sure what's going on. I think there is something that needs to be reset somewhere, but I can't do that while I'm live, unfortunately. It's just while I'm on this particular screen. I think it'll be fine in a second. It's probably also because I've got the Arduino IDE. I've got quite a few things running on here. It is a Mac M1, so it should work fine with that. Anyway, so the other one I wanted to mention as well is the, yeah, it'll catch up. Yeah, so the other thing I wanted to mention as well is if you want to support the show, you can help me out as well by going to buymeacoffee.com/KevinMcAleer. You can buy me a coffee. So that can help pay for all the equipment, hosting, graphic software, streaming, stuff like that. You know the works. Cool. So that's the that's my bit out of the way. Let's go back to here. So let's code. Great stuff. Let's get over to some code. Okay, so let me just jump back to me for a second. And what I'm going to do, I'm just going to check and see how we're doing on the activity monitor. Sometimes it plays up like this. I'm not sure why. What I'm going to do is I'm going to remove that and see if that's any better. Its Ecamm is really using quite a lot of resources there. I'm not sure what its problem is. Okay, let's just move that out of the way. And let's get to, so let's go over to the Arduino IDE first. Let's see, there we go. Let's go to, just trying to find the best view. There we go. So what I've got over here then is, this is the Blink program. You're probably very familiar with it. It flashes the LED once on, once off, once per second. And if you go to the Arduino IDE, you go to, let me just find it on here, new, I think it's Sketchbook, examples, basics, and then Blink, you'll find this exact program. All I've done to this program is just added in a little bit of text so that it shows something on the serial monitor, because I want to show you that too. So what we've got on this program, if we look at the top, we've got lots of big comment section here. So that's just star forward slash, is it? And then, sorry, forward slash star and then star forward slash to kind of make a block of comments. So I'll have a look at how we do that for the MicroPython in a second. Then we've got void setup, and we've got some squiggly brackets. We've got another comment, but this time it's a single comment, so it's got the double forward slash. And then we've got pin mode, LED built-in output, and then we've got serial.begin, which is how we do output to our serial. So what I'm going to do, I'm going to open up Thonny, and I'm just going to wipe that for a second. And I'm going to write the exact same code, but this time I'm going to do it in MicroPython. So let's just write a block of code. So if you want to do a comment block, we can use this 3 lots of speech marks. So this is a comment block. And comment blocks can be multiple line. So multiple lines. And we can also have just a single comment, which is the hash. So if we use that, or the pound, I think in American, we call that a hash in the UK because a pound is that symbol for us. So if this is a single line comment, and you can also have, see if I just do a equals 1, which is just setting a variable to 1. If I put after that the little pound thing, this is an inline comment, and that's like doing the double slash like we have down here on the Arduino. So let's just get rid of that for a second. So what we will do, instead of doing void setup, we can just start typing straight away on MicroPython. So if we want to do pin modes, what we need to do is bring in the pin from the machine library. So we say from machine import pin, and pin has a capital P because there's a convention when you're using classes, you always use capital letters for that. So we don't need any, we don't need that character, the dot and the comma, semicolon. We don't need that at the end of a line on Python. We can just do a new line. And if we want to set an LED to a value, so let's just create a variable called LED, and we'll set that to the value of 25. I'm going to make that actually a pin 25, and that will represent the built-in onboard LED, which on a Raspberry Pi Pico is just at the very top of the board, just about there. If I can hold that up so it can focus, just where my fingernail is there, that is the built-in LED. So that's pin 25. I think it does say that on the diagram. Okay, so that's how we set that up on MicroPython. So then next, serial.begin. We don't need to do that on MicroPython. We can just print things out to the REPL just by using the print command. So for example, we could just say print Blink is starting, like so. And that's going to flash a little. So I'm going to plug in the, let's actually plug in the MicroPython device, our Pico. Bear me with while I do that. And let me just see if I can see the files. I'm just going to go to the files option on Thonny. And if I just stop and start it. Let's just see. Oops, it says it's busy. Let's just do that. Sometimes it plays nicely, sometimes it doesn't. There we go, that's appeared down there, that's a good sign. Let's see if it's going to do that. No, it's not. Right, I'll come back to that in a sec. Oh, there we go, it's appeared now. So we can now we can save this Blink, save Blink, and if I run the Blink program, Blink is started. So you can see there, this is the REPL, this is the read, evaluate, print loop. So I can run a little snippet of a program here, and it's going to output whatever I type print just here. That's actually running over the serial, the UART, just like the Arduino does. But on the Arduino, we have to bring in the serial library. We have to say serial.begin, and we have to specify what the baud rate is. Whereas on the REPL, we don't need to do that. It's implicit. It is already running at that kind of baud rate already. So then next, we have a loop. So all Arduino programs have the same kind of setup. They have a setup function, and then they have a void loop main loop to the program. And the idea here is that you have some code that initializes everything that runs just once, and then you have the main body of code in the loop that runs over and over again. So once the main loop has run this code and it gets to the bottom, it will then go back to the very top and run again, and it'll run until the device is, the power's removed. So in MicroPython, we don't have that. You've just seen when I click run on there, it runs it once and then it stops. It goes back to the command line again, the REPL. So if I want something to run and run and run, the convention is you do while true, and then you type something such as, we're gonna make a little program that will flash an LED. Now we could just say LED.on. And what we could also do, after we've got the machine import, we can sort of say from time, which is a time-based library, import sleep. And then down here we can say sleep for 1 second. And then we can say LED.off, and then sleep again for another second. Like so. And if I run that, because it's while true, it'll run forever. Now if I go over to, let's just see if that's actually running there. What am I doing wrong? That doesn't look like it's running to me. I just need to check what's going on there. So if I go over to here, what I'm expecting to see is that there's like a little flashing LED there, and I'm not seeing that at the moment, so I'm just trying to figure out what I've done wrong there in my code. So machine pin, time, sleep, pin 25, LED on, LED off. So what I've not done there, if you look over in the Arduino code, you can see there we've got this output. So what we're saying there is we're setting the pin mode to be either an input or an output, a digital in or a digital out. We do need to do the same thing here on the MicroPython code. So we do pin dot and then out in capital letters. That's the convention there. So I just need to do Command C there, save that again, and then run that again. Right, so now you should be able to see that that LED is flashing on and off once every second. There we go. So that's the same kind of code that's been written there. So when we've got delay in Arduino, I've just simply used sleep, and delay takes, is it millionths of a second, thousandth of a second, milliseconds? Milliseconds. Whereas the sleep function just takes seconds. Now there are other functions that we can use to mimic that, but the convention there is we just do 1 for 1 second. Now where we've got this, I've added this code here, serial.println high and serial.println low, because if we want to see what's going on behind the scenes in our Arduino code, we need to go to the serial monitor. So if I just go back to the full screen for a second, and I go up to the menu and I go to serial monitor and I open that up. Oh, I've actually not got it plugged in. Let me just see if I can get this plugged in. I'm just going to have to unplug that microbit for a second and then plug this in. Okay, just let it wait for a second while it finds that port. Let's make sure it's on the right port. It's an Arduino Mega that I've got plugged in. I've got a regular LED bulb that we can actually put onto between pins 13 and the ground. So if I just do that between pin 13 and the ground, we'll get a nice big light like so. There we go. That's a bit brighter. So you can see that's flashing away once a second. Now if we go to the serial monitor now, so if I go to Tools, Serial Monitor, now let's go back to the full screen so we can see this. Then we've got the serial monitor opening up, and we've got high, and then it should say low, and then high, and then low, and so on. We've got high, low, high, low, high, low. Perfect. Great. So that shows you that, and that's one of the ways that we can debug code on Arduinos, because we haven't got any other way of understanding what's going on inside its little brain other than printing things out to this console via the serial port. But we do have to set up things like, what baud rate it's on, is it having new lines and character returns and all that kind of stuff. On MicroPython, we don't need to worry about all that. It's already kind of taken care of for us. So let's have a look at some other things as well while we're here. So on an Arduino code, we have void and then setup and then the brackets, and then we have these little curly braces to define the block of code. And at the end of each command, we have a semicolon as well. So let's go back over to our code over here, and let's have a look at how we can structure code similarly. So what I'm going to do, I'm going to create a new function that will blink the light on and off. So instead of having void means that it doesn't return a value. So if you want a function to return a value, then you need to say what kind of value that's going to be. Is it going to be an integer? Is it going to be a floating point number, and so on? So if in our, I'll create both pieces of code on both languages so we can compare the differences. So on MicroPython /Python, we use we define a function using def, and we give it a name, and I can talk about cases as well while we're here. So I'm going to call this LED_blink, and I'm going to use all lowercase to describe that function. So if I go over to the Arduino here and I do the same kind of thing, I'll do void because I don't want it to return a value, and then I'm going to call it LED, and then I'm going to do no underscore, I'm going to do capital letter blink, and then I'm just going to do brackets, and then I'm going to open my curly braces up. So this is called camel case. So if you think about camel, you think about it kind of goes like that, and then it has a bit of a hump, and then it kind of carries on the shape of a camel. So this is called camel case because it starts out in lowercase, and then it has an uppercase character to define the new, the new word, but the words are squished together. So that's camel case. Some people have a capital letter for both, and that's still legitimately because you can have camels with two humps. Now on Python, we don't use that, we use snake case. So snake case is the preferred way of breaking apart letters, and we prefer this because it's just easier to read, and we tend to have everything in lowercase. The things that we have in uppercase are classes. They start with they're kind of sentence case, they have a capital letter to begin with, and constants are also in uppercase. So where we've got the LED pin being 25, we could, for example, say LED underscore pin, all in caps, equals 25, and then we could change that to be whatever value is in there, like so. It recognises both of them there. So then what we're going to do now is we're going to define what this code is going to do. So I'm just going to cut and paste that code from there to here. I'm just going to tab that in because the tabbing is important, and we'll get on to why that is in a second. Like so. So what's going to happen, that while true is going to run that LED blink function, and the LED blink function is going to run this code here. Now notice we didn't need to do those squiggly braces because in Python the indentation is what defines the block of code. So we've got LED actually tabbed in by 4 characters. You can see there, we've got 1, 2, 3, and then the space 4. So we indent by 4 spaces to define a block of code. And that actually makes it easier to read on the eye because you haven't got all this extra stuff that kind of clutters up your view. So when you're looking at C code, you've got to look at all these extra bits at the end of each line, and you're doing this because the compiler wants to understand what you mean. And with Python, we can imply that by the structure of the code. So that's one of the reasons people like Python. It's kind of a cleaner language to understand. So that is how we do a function. Now, if we wanted this to return a value, so say after we've run this, we want to say return true. Notice how true has a capital T, false is the same, that has a capital F, but we're just going to return true. So once this is run, so we can actually use that down here and say if LED blink, and then we use the, is that the semicolon? Oh, that's colon, isn't it? And then we say print run LED blink. Like that. I just wanted some code that does something, oops, like so. Now notice I've done a couple of things there. The if statement is going to check if this is true or false. So we don't have to say equals true. We can just say, is it true by saying if? Because if it returns false, then it won't run this piece of code. So down here we could also say else, and then another colon, and then it indents again. It does this automatically for us, and again this is because this is a block of code. We might have several commands under here. Otherwise, we can say it did not run, like so. So if we change that to false and we run this, let's just stop that and then click that. Oh, I've not got the Pico plugged in, so I'm going to have to unplug that and then plug that in. Let's give everything a second to catch up. Right, let's just try that again. It might just take it a second to figure out that it's got a Pico plugged into it. Let's just try that. I'll just flick over to a different one and then back again. Always seems to be a bit finicky, this, I've noticed on Thonny. It's one of the reasons I don't really like it. It can be a bit awkward. Last time I said, oh, let's just ignore this, and then it started to work. So let's just ignore this and then carry on with the code. So if I say return, see what I mean? It's decided to do it now. So if I click run now, it says there's an error on line 17. So and that's because I've not done the colon there. No, that's not right, is it? Yeah, no, you do need that actually. Let's try that. There we go. Sorry, right, so LED is blinking, red LED blink, because it's returned true. If I change that to false and I run this again, it should say it did not run. Let's just stop that and start that again. Do I need to do Control C? Come on, Thonny. Yep, being very silly there. Stop. I'm not going to use this now. Come on, start working again. There we go. Maybe it's voice activated and you have to insult it. Right, now it's saying it did not run, even though it actually did run, just because it's checking that return value there. So each function can return a value true or false because we've told it to return false. Now we could make it return a value like 1, 2, 3, 0.1, whatever we want, anything at all. It could be actually a number of values. It could be, you could say return 1, 2, 3 like that, for example, and it will return all those values. Or if we just leave it out, then we don't return any value. So let's just get rid of that in there again for a second. Just to clean up our code, and then let's have a look over here in how we would do the same kind of thing for our Arduino program. So I'm going to copy all that code that's there. Let's just copy that, paste that, like so, and then down here we will do, oops, I've done it in the wrong place there, haven't I? Let's do it there. And let's go down here and just type in the name, which is LED Blink, like so. So that will run fine. So if we want this to return a value, I think it is return as well on in C, isn't it? And then we do whatever value we want to return. So if we say true now, in Arduino C/C++, true is lowercase and false is also lowercase. But if we're going to return a value, we need to change what this is. So if it's going to be a true or false, that's called Boolean. So we need to set it of type bool at the beginning there to say. So we have to define ahead of time what things are going to be. Now this is one of the main differences between Arduino and Python/MicroPython. Your variables are what type they are, and we call this strongly typed. So if I go up here at the beginning of my code and I say let's create a variable that's called a, and I'm going to make it an integer, like so. I'm going to set it to 1 initially, and let's have a floating point thing that's b. I'm going to set that to 3.14. And let's have a Boolean value that's called flag. I'm going to set that to false. Oops, false. Like so. We have to define what they are up front, and what happens to the compiler is it detects this and says, right, so you've got a symbol that you're calling a, it's going to be an integer. I'm going to take 2 bytes of memory, and that's going to be that symbol a, and I'm going to store a value of 1 into that area of memory. And then when it comes down to the floating point, and when it goes, great, I need 4 bytes, or whatever the floating point accuracy level is, and it will store an area of memory for that symbol as well. Python works very differently than that. So we can actually define variable types on the fly And you might think, well, that could be dangerous because what happens if we don't define it correctly? So let's just go back over to our Python and we will say a equals 1. We'll say b equals 3.14. And we'll say flag equals false. So that's as easy as that. We can use those in our code and we don't need to worry about what type they are. The type is implicit. And again, this is one of the reasons that Python is cleaner. We don't have to sort of waste time defining what things are. Python is intelligent enough to figure it out from the content of it. So similarly, if we came over here and we want to create a string, so let's say, let's call this username equals, and then we do Kev or whatever, and we have to say that that's of type string, which is this is a piece of Arduino code. There isn't such a thing as string in C. You've got pointers to characters and things like that, but you haven't got string per se. So over here in Python, MicroPython, we can say username equals Kev, like so. So it's intelligent enough to know what these are. So let's just actually stop this code running down here. We can actually play with these things. It's a bit like playgrounds in Swift, if you've ever used Swift. So we can say a equals 1, and we can just say a, and it'll print out whatever value is in A. So if we say B equals 3.14, and then we print B, it knows that that's a floating point, 3.14. If we say flag equals false, false, and we type flag, it knows that that's flag is false. Now, if we want to figure out what type these are, we can actually use the type function, and we can say what type is A. A is of class int, which is an integer. What is type B? B is a float. And what is flag? Flag is a boolean. And if we have username equals Kev, and we do type username, it will say it's a class string. They're all classes, if you notice as well. They're not types, they are classes, and that means that there's more to them. So if we want to return the lowercase version of our username, I can do username dot, and then there's all these extra lower things like that. For example, lower. So Kev is now lowercase, or I can do upper, and Kev is now in uppercase because it's a class and it has lots of different things. I can say username dot is lower, and it's not lowercase, it's sentence case because it has a capital K. I can say is upper, and that's also false because it's got a capital K and it's not got all the rest of the letters capital. So there's all this extra stuff that you get for free in Python because they're not types like foundational types, they're classes, and it generates these on the fly, and you can change the type of something on the fly as well. So we said a equals 1 before. If we say a equals 1.1 and we do type a, it's now a float. But we can use that is instance. We can say, is this of a particular type, if we need to make sure that somebody doesn't give us the wrong value when we're creating something. And we can do that by just, they call it a code hint. So in my little definition thing there, let's say I have a number of times I want the LED to blink. So let's have something that's called count, and we will say for n in count, is that right? For n in count, and then let's just tab these in. It should blink it however many times we pass to in count, but I'm not going to tell you what count is at this point. I'm just going to say in there 4. So let's do that. Run our code. Line 32. That's why I didn't like that little ending that we had there. So int isn't iterable. In range. That's what we need to say there. And then it will flash 4 times, and then it will go back round again. Because we've got this running ad infinitum, let's actually get rid of that and just have it running once, just so we can see that it runs 4 times. So it should blink 4 times and then stop. if this stupid thing starts working again, I'm not going to bother running that code every time. All right, Blink is started. So it's going to flash 4 times and then it's going to stop. So it's about 4 seconds worth and then it stopped there. So we could actually go over to our split view. My Stream Deck's playing nicely. I think it's the Stream Deck that's... no, I think actually I know why everything's running slow. So my Mac has actually got a low battery at the moment. And I think that's what's causing the issue. I think it's gone some kind of like power saving mode at the moment. And everything seems to be running at sort of half speed. So anyway, so I'm doing quite a few things here and I want to explain what I'm doing. So for loops, we have for loops in Arduino. We have while loops, for loops, and do we have repeat until? I don't think we do we? That's Pascal. So we have for loops and they work very similar. So if we come down to our main loop here and we say for n, God, this has been a while since I've done it in here. I think you need brackets as well, don't you, for this. Then we say something like n less than equal to... I'm going to get this completely wrong now because I've not done this for so long. Is that right? No, n equals 0. N is less than 10, and then n plus plus. We'll get on to plus pluses as well in a second, and then we need to have our little squiggly brackets again because it's a new code block. Let me just see if that compiles. It's been a while since I've done this. I think it's not commas, is it? It's semicolons as well. Beat the compiler. And that's ugly code. That doesn't really make sense. I mean, what's going on there is we're saying, right, let's create a variable that's called n. And we might even have to say int n because it's never seen n before. N equals 0. Then n is less than 10 or whatever the loop count is. So let's change that to 4. And then n plus plus. Plus plus, where C++ kind of gets its name from, is a way of saying n equals n plus 1. So whatever n equals, n will start off as 0 because we've defined it to say start off as 0 there. Then when it does this loop, it'll go around once and it'll be 0. And then when it gets to here again, it'll say n equals n plus plus, or just n plus plus. So n will become equal to 0 plus 1, which is n1. Then it'll run around again. And it'll do that until or while n is less than 4. Once it's gone greater than 4, it'll come out of the loop. It's horrible to look at that. I mean, when you're coding, you'll get used to that kind of thing, but it's not very intuitive. Python, on the other hand, is a bit more English in how it works. So, for example, let's say this flag thing here. If we want to check what the value of flag is, we can say if flag is not none or not false, then do some piece of code. And we can just tab that in like so. This is where I think we should be using Visual Studio Code because you can just do command and then the square bracket and everything just shifts over a little bit. But if flag is not false, I mean, it's English. It's nice and simple. The range thing, for n in range count, range is like, is it between the range of 0 and a number? But if we're not saying 0 and a number, we can imply that it's between 0 and a number. Therefore, we just put the number in. So n is our temporary variable that we're going to use to just loop over things, and we're going to say loop over it 4 times. That's essentially what that loop there does. But we do need to just move all that code back a bit because it's too much indented now, and indentation is quite important in Python. So we just need to move that back. So let me just check my notes as well, because there's a few other things I wanted to cover off on there. So void defs, I've talked about them. Variables and types, we've talked about that, including import. Right, let's have a look at that. So on our Python code, we have looked at from machine input pin and from time input sleep. I think I'm going to quit one of these programs because it's clearly not running very fast on there. I want to show them both side by side. So this is a bit annoying. What else is there? Let's have just a quick look. Right, so you guys are getting buffering issues. Let me just have a look what's going on. I think something is up with eCam. Let me have a look. How is that? I've just switched off. I've taken out my camera. I'm going to quit Arduino. Let's just quit that for a second. Yeah, eCam is really struggling for some reason. I don't understand why. What is going on, Mr. eCam? Let's go back to me for a second. Let's quit that. Yeah, it's not you, Tom. I think it's my eCam. It'll be my stream going out is probably not quality. Yeah, you're having too much buffering, so you're out. No. I'm trying to fix this. I could tell by looking at myself in my little confidence monitor there that I was streaming not very smoothly there. It should pop up and tell me if there's any streaming issues though. It's still doing 130